Today we're going to cover quadratic functions, section 4.1. Up until now, you've dealt with linear functions. Now we're going to deal with quadratic functions. Let's look at some real-life examples here. But before we do that, let's look at parabolas. What is a parabola? Basically, it's the shape. Okay, if we're looking on a grid here. Here is the shape of a parabola. Like this or like this. These are also parabolas. Okay? That's what a quadratic function produces on a graph, what we call a parabola. What does a linear function produce on a graph? It produces a line, right? There's a line. What does a quadratic function produce? It produces a parabola shape. Okay, what are some examples of parabolas in real life? McDonald's. Those big arches there. We got that right there. We have a satellite dish. If you think about it, if you can't see it here, I mean, you look at the outline of this, it's a parabola shape. Yeah? A slinky. Anybody ever have these before? Old school parabola. Okay. Let's get some notes about parabolas or quadratic functions. Right here, that point is called the vertex of the parabola. Now think about folding this thing in half. Think about taking both sides here and folding it in half. Do you know where it would fold in half at? Right down this line, right? You can fold both sides together. This line right here, right in the middle of the parabola, this is called something. This is your axis of symmetry. These things are symmetrical, okay? Now you know what a quadratic function looks like on a graph, a parabola. But what does it look like as an equation? It looks like this. Y equals ax squared plus bx plus c. So what gives it away? The x squared. That's the highest degree. Notice a linear function off the side. You don't have to write this down. A linear function is like y equals mx plus b. Notice x is to the first power, y is to the first power. Notice this one, x squared. That's what makes it quadratic. The highest degree is x squared. Now, that's what it looks like as an equation. Okay? Now, notice or note that this is the standard form of the equation, where a, little note, cannot equal 0. What if a was 0? 0x squared, then that would just be, it's linear, right? So a can't be 0. Let's go back to the vertex for a moment. The vertex, what's the definition of vertex? It is the lowest or highest point on the parabola. Okay, right now that's the lowest point, right? All these other coordinates on the parabola are higher than this. So this is also called, in this specific case, since that's the lowest point, this vertex, that's the minimum. Okay, that's the minimum point right there. We're going to know how to calculate the minimum later. Alright? If I drew another one, if I drew another parabola, let's say I drew it here, okay? This right here is a vertex, and that's the highest point. So that point right there would be the maximum in that case, right? So your vertex is either going to be where your minimum is, or your vertex is either going to be where your maximum is. This function right here in red, this parabola, this is y equals x squared. So y equals x squared. And this is your parent function. Remember parent functions from linear functions, y equals x. Remember parent functions for absolute value functions, stuff like that. This is the parent. Everything else are like the kids, right? So what we're going to do now is we're going to have you graph y equals 2x squared. But before we get to that, can you picture your axis of symmetry for the parent function? Right here? That's a line, right? Every line is denoted by an equation. What equation represents this line right here? Since it's vertical, it's x equals, right? X equals what? X equals 0. Question is, how do you find that? Well, there's an algebraic way to find that. We'll get to that in a moment. But let's go to your calculators. Everybody get out your calculator. And we're going to do the next or first example. Graph y equals 2x squared. Compare the graphs. So we're going to compare again, okay, to the parent. So let's go to our calculators. First off, let's put in y equals x squared. How do you do that? You type in x, and then you type in x squared right here. So it puts a little 2 up there. Graph it, and you see that's what it looks like. Just looks like the last graph that was on the PowerPoint up here. Now, what we're going to do is we're going to graph the other one. So go back to y equals. Maybe in the second one put 2. Oh, not cosine. 2x squared. Let's see what that does. Press the graph key and look what happened. It made the graph narrower, right? This second one made the graph narrower. Quadratics are similar to absolute value if you remember. The a value off to the side here. The a value for absolute value did what? It made it narrow, it made it wide. It also made it go up or down. That's what this a value is going to do as well. Alright, so if we go back to our calculator, let's say we put in, let's say we go to insert a negative sign. What do you think would be with negative 2x squared? Well, what did it do for absolute value? It flipped it down, right? So that's what it's going to do here. If you look at it, it just flipped it down. Now, did the width still say narrow, right? Because the 2, it's narrow. And the negative flipped it down. So that's what's happened. What happens when you make a negative. So let's see what would happen if we put negative 8. In your mind, take a guess to see what would happen. Would it get wider? Would it get narrower? Would it go up? Would it go down? Well, the negative makes it go down, but what would the 8 do? Well, let's look. It made it narrower, right? So think about that number. And let's go back here and say, let's make some notes about a. If a is negative, then the graph goes down. You can make a little graph for yourself and make it go down. Okay? And then you can write down if a is positive, and it goes up. Sorry, my notes are sloppy here. So, you can make one that goes up. Okay, example number 1, when we're supposed to compare y equals 2x squared with the parent. Notice the red is the parent. Let's go graph y equals 2x squared again. So what you want to do is put it in your y equals button in your calculator, just like this. What I could do is I could go turn the other one off, turn the other graph off by going on the equal sign. Notice the one is highlighted, 2x squared. If I look at the graph, there's 2x squared. But how do you graph this? I don't want to sketch. You want a good graph with good coordinates. So you could, by hand, plug in some x's and get some y's if you want. Or, based on the calculator, go to your table. Notice up here, table. So to go to second table, and right here is all your coordinates. So let's put these on the graph over here, okay? So this is how you graph. Step 1, type it in the calculator. Step 2, go to your table. Pick some coordinates. Notice where the vertex is. In this case, it's 0, 0. And then plot some coordinates and draw a curve. Not like an absolute value. Absolute value is a v. This is a curve. So let's plot these points. Negative 2, 8, negative 1, 2, 0, 0. So can't plot negative 2, 8 at the moment. Negative 1, 2, and 1, 2, 0, 0. Here we go. Negative 1, 2, 0, 0 is the vertex for mine, and 1, 2. And draw a nice curve. Oh, mine's bad. Okay, but you get the picture. Nice rounded out curve if you can. Okay, mine looks more like a V, which I told you not to do. Okay, now there is your y equals 2x squared. If it was y equals 8, it would be even narrower than that. So if I was to compare, you would say y equals 2x squared is narrower than the parent. And it has the same vertex. Also talk about vertex. In this case, they're both the same. And then you would say is narrow and it goes up. How do you know it goes up? Based on positive 2. Okay, so that's how we compare. That's how we graph. Put it in the calculator. Get your table. Compare. Look at them. Is it narrow? Is it wide? So what would make it wide? This would make it wide. Y equals 1/3 x squared would be wide out here. Okay, so let's put in 0, 0. I'll even draw it real quick. 0, 0 is the vertex. If you put in 0, you get 0. Put in 1. When x is 1, what is y? 1/3 times 1 squared is 1/3. So it would be right around here. And so it would be right around here because it's symmetrical, remember? Put in 3. If you put in 3, it'd be 9. 1/3 of 9 is 3. So 3, 3, negative 3, 3. And look how wide that is. Draw a nice curve. Okay? That's how you graph and compare. Is it narrow? Is it wide? Does it go up? Does it go down? Those are the main ideas of graphing and comparing. Alright, example type number 2. Graph this guy right here. Notice it has a C value. Think about what that would do. All it is, your C value kind of moves it up and down here. So, if I told you to graph it, what would you do first? Number 1, you type that in the calculator. Yes, you can use your calculators. Okay, when you go to your calculator, you type it in y equals. Go ahead and do that. Take a minute. Then look at your table. So here is your table based on your calculator. Now, you want to figure out where your vertex is, where your axis of symmetry is. Okay. So to do that, you need to know this right here. X equals negative b divided by 2a. Know that formula right there. It's going to help you, especially with the next ones. This is to find your axis of symmetry. Okay. Okay, to finish up this problem, you need to plot these coordinates on the graph as shown here in the red, and you need to compare it to the graph of the parent. So this 1/2 makes it wider than the parent, so you have to tell me wider, and you have to tell me that you also have to tell me that it goes down. So wider and down. That's how you compare these graphs with the parent. Alright, this is where I have to stop. I actually have to go to the retreat right now. So here's what I want you guys to do. I want you to read the key concept on page 237 that tells you a lot about the properties of the quadratic function, and then try to do example 3, only up until example 3, and then therefore the homework, your homework is, it'll be on the website too, but section 4.1b, only numbers 1 to 12, I believe. Okay, you guys have a good week, good day without me, and see you next week. Please do up into example number 3. Know your stuff. Have a good weekend. Bye-bye.